Hello and welcome to the show. It's me, John Park, and it is time for JP's product pick of the week. And I am excited because this week we have a, what do we call this? A combo discount extravaganza. Those were Lady Ada's words. That's right, we have two product picks this week, which go well together. They play very nicely together, and I'll show them in some demos in a second. So thank you for stopping by. Thanks for hanging out. We have the chat over in the YouTube. Hello, Dave Odessa and Fish Up Bishop. Welcome. Thanks for stopping by. Hope you're having a wonderful day too, Fish Up Bishop. Thank you. Also, if you're somewhere where there doesn't seem to be a chat going on, such as Twitch or Facebook, you might want to head over to our Discord. So that is right here. It looks like this. That is at adafruit.it/discount. Not /discount, /Discord. I have a fuzz on my glasses that was just distracting me. It's never going to go away. It went away. What did I say? It's at adafruit.it/Discord. That's the Discord that you see right there. And if you are coming over there for the first time, check out the live broadcast chat channel. That's the one that I have highlighted there, and that's where people are hanging out during the show. People such as Sam J. Ohio, Super Daddy, DJ Devin 3, Jim Hendrickson, Gary Z. Hello, thank you for popping on in onto the chat here. Hope I didn't miss anyone. And what's going on? What do we have here? So, like I said, there are two product picks this week, which means you've got some choices to make. You can head to both of those QR codes there, or to these URLs. It's products 5882 and 5888. Jump on in there. This show is, this actual live stream is taking place right inside of those pages. I'm double checking there, but the product team, Jelly, Travis, and others have been hard at work. I know it's harder when we have two products like this, so thank you so much. We appreciate the extra effort. And they have stashed away some of these so that there are a bunch of them ready for sale, and they are half price. So head on over to those two URLs there. And before I say much more about it, what we'll do is jump back to the new product segment from the Ask an Engineer shows where these first appeared, and Lady Ada is going to tell us about these two products. Oh, my volume is a bit low, eh? Let's see. Let me put that up a little bit. I don't want it to peak out, so let me know if that's good there, Jack Frost. Hey guy, volume's a bit low. Adafruit, right there. Thank you. Thanks for the note. All right, so here comes Lady Ada with the newness.
It's the Power BFF. This is coming soon. We didn't quite get all of the demos in, but I thought we would at least highlight if people could sign up to chat about this on INPI. But this is a board that lets you have 5 to 12 volts DC input, and it will let you plug in your SHA or QT Py board on top. You also have a terminal block, which you can use to get that power out, or you can have power come in from the terminal block if you have a battery pack. And it features the NPM 3610, so it's a DC-DC buck converter, so it's very efficient, and it'll give you a nice clean 5-volt, 1.2 amps out. I'll be honest, I actually got 1.5 amps out when I did my load testing, but it's rated for 1.2. And then there's little mounting tabs, because if you're going to plug it into a DC jack, you want to have some mechanical strength. So the version you'll get in the shop, you see has these 4 little mounting hole legs, and you can break them off if you want it to be more compact. And then I'll show just a prototype real fast. And next week we'll have like a bigger, better demo. But this is my prototype before I added the legs. You can just plug into the DC power here. Maybe I can plug in here. See if this will work. And then boom, now it's running CircuitPython. It's blinking. Oh, focus. Yeah. And you can do like this is, I think, a 9-volt. But we want to do some projects where we wanted to power the QT Py from like a car or from a DC or battery pack where you wouldn't necessarily get 5-volt clean. So this will convert it down to 5 volts for you. So it's coming soon. You can sign up, and we'll have it in the shop maybe later in this week. Yay, it's the NeoRGB Stemma board. This is a board I designed for myself because I was so tired of wiring up analog RGB LED strips with transistors and resistors and power connectors and like whatever. I want to make it really easy to control analog LED strips. That's LED strips that don't have neopixels in them. A lot of them use they use 12 volts or even higher, but 12 volts is the most popular. And so now I have a board where you have NeoPixel signal in, like your standard NeoPixel that comes from any microcontroller or even a Raspberry Pi these days. And on the output, you have 3 common anode RGB channels, plus power and ground. They connect to the terminal block. And it acts like a single, very, very bright, very large NeoPixel. You can also use this with anytime you have like an LED array that has PWMable inputs. This will basically do the PWMable control, 8 bits per channel, 24 bits total. And then you just treat it like a NeoPixel. So, again, wonderful if you have analog neon or LED strip or something for some reason you want to, they're definitely for long extensions. They're cheaper than using NeoPixels, and you don't have individual LED control within the strip, but maybe you don't need that. Maybe you want to like do a single color for the entire thing. So I have a demo on overhead. So this is my standard Atmega 328 Metro Arduino compatible, and I'm powering it from 9 volt here. So this is 9 volt power. I connect the red wire to the Stemma board from VN, so it's 9 volts, ground to ground, and then the NeoPixel signal. It thinks it's connected to a single NeoPixel, pin 6. This is a bright power LED telling you that the power is good. You can barely see it because it's only one LED, but there is a little bit of blinking going on the signal red LED over here. And then you just use the terminal screw block to connect red, green, blue, and then this black wire is VN, so it's the 12 volt power. And then this just acts like a NeoPixel, it's doing the NeoPixel swirl. So it's great because this can handle 3 amps per channel up to 16 volts. So if you have like a gigantic star RGB LED, or again, like you have a gigantic plate or analog LED strips, and you don't have to be RGB LED strips. If you have white, like cool, warm, or natural white, or sometimes there's LED strips that are analog that have color mixing, so you can change from cool to warm to neutral white. You could basically have this act as if it was a NeoPixel, and again, make it a lot easier to control. If you're using more than 2 amps total, recommend not going through the JST-PH, just go through the terminal block. So you just power directly from the terminal block here. And you can control, again, 9 amps total between all 3 channels. One thing I will mention is that if you're using RGBW LED strip, this only supports 3 channels. I haven't quite found a chip that supports 4 channels yet that is NeoPixel compatible. So you have a choice of either just controlling 3 of the channels, or there is, an output pin here if you want to chain. You could connect the 4th channel on a second one of these and then just control it as if it was the second NeoPixel afterwards. You'd have to do the logic for it. You treat it as 2 NeoPixels. The first one is RGB and the second one is just W. But I'll let or sometimes, again, some strips have 5 channels. Again, you'd use 2 of these, 1 for each set of 3. So I think this will make wiring a lot easier for people, definitely make my demos a lot faster. So hopefully folks enjoy it. I know Erin, who does a lot of NeoPixel projects, has already been excited. She's like, yay, I can't wait to use this to already simplify some wiring on a project I did for a tiki bar.
She had me at tiki bar. So these are my product picks of the week this week. It is a dual combo discount extravaganza. We have the Power BFF and we have the NeoRGB Stemma. So the Power BFF is made for your Cutie Pie to stick onto the top with some header pins, and in fact it comes with the sockets that you need. So you'll solder those onto there, and then you'll solder some male header pins on the bottom of your Cutie Pie, slot it right into there. I'll show you a demo in a second. And what that allows you to do is plug in 5 to 20 volt DC, either into the barrel plug here. This is a 2.1 millimeter barrel plug, pretty typical for a DC power supply, or to the terminal block. These are joined, so only plug into one of them as far as an input goes, but you can use the other for output or kind of a pass-through. So you'll plug in power up to 20 volts. It will use the buck converter to give you a nice clean 5 volts to drive the QT Py, but this means that you still have that same 20 volt, 12 volt, 9 volt, whatever it is that you gave it, available to run another gizmo, which is really the sweet spot of using this. Another really nice feature of this is it has some mounting holes on it, so you can screw that down onto your project. I'll show you that in my demo. And the reason that we combined these is the other one here. This is the NeoRGB Stemma. So this is a really cool board, really clever. Normally when you have analog strips, particularly analog LED strips that have the 3 LEDs mounted in them, red, green, blue, they're not neopixels. You can't control them that way. So you have to set up 3 FETs in order to control them, these transistors, and then the code can get a little complicated. This is really neat. What this does is it allows you to take your NeoPixel code, send it to this as if you think you're using 1 NeoPixel, and it will then split out those as PWM signals onto the 3 common anode, so red, green, blue outputs that we have here, and then you'll have the voltage pin also connected. Usually you'll have 4 wires on these types of strips. And then you just talk to it like it's 1 NeoPixel. The whole strip will change colors, fade, blink, anything you want to do, just like you're used to using your NeoPixel code. And you can do that with the Arduino, with the CircuitPython, even WLED. Makes it really easy to use. So let me show you a few things here related to these. First of all, let's take a look at the product pages on these. Let me jump over to this right here. Okay, so here we have, if we refresh this, just want to make sure they're in stock. So we have 78 of these in stock still. Half price, so you just throw that in your cart. You don't need a coupon code. It's priced right now at $3.98. So there is, you can see on there, we have the barrel connector. We have the terminal block there to screw your output if you're going to be running something off of this besides just the QT Py. Here it is on the underside there. This also has a like a reset or enable type of pin, enable pin and a reset pin, so you can wire up some switches to it if you want. And here's our second one. So this is the NeoRGB Stemma. You can see here, this has a 3-pin Stemma connector. So you can use that to connect up to your power, ground, and NeoPixel signal that comes onto this board, and it's going to output to that green terminal block there the PWM signals you need to control the 3 colors of the RGB strip. Now you can power this in a smaller set right off of that voltage in from your microcontroller, but more likely you're going to have a bigger power source, which is why I combined these two. So let's take a look real quick. Here is the Learn Guide for the Power BFF. So this will take you through, show you how to set it up. You can see there's a nice picture of a QT Py docked on top of it there. And here it's being powered off of a battery pack. You can use that on the terminal blocks or with a barrel connector or with a wall wart, regulated power supply, however you want to control it, or power it rather. And then here is the RGB, the NeoRGB Stemma in action. There you can see it's connected up to a Metro board, and it's actually getting power from that. But in my case, I'm going to be doing it a little differently using that Power BFF. And these are the types of strips that you'll typically run. So those look like a NeoPixel strip, but they're not. These are single color, or rather the whole strip is going to be 1 color at a time, but it can be, the whole strip can be changed multicolor. Typically you'll see these in room, running LEDs around a room just to give it an overall color shift, but it's not going to be animating individual pixels. That's a NeoPixel, and this is not that. This is an analog strip. Here's another nice example of one. So that's an RGB analog strip. You can control the whole strip, different colors. One thing I'll also mention is you can, if you want to, connect up multiple strips to the 3 different outputs on here, so you could get yourself a fully red strip, a fully green strip, and a fully blue strip, and then combine those as if they are one big huge NeoPixel or one big huge analog RGB LED. So depending on your use, you could drive all of those off of this still using NeoPixel code. So let's take a look at a couple of examples here. I'm going to jump to the down shooter here. Actually, let's go to the full. This full down shooter view. So here you can see what I've got set up. I have the Cutie Pie plugged into the Power BFF. Power BFF is mounted to one of our little swirly grids. I have a 12 volt, I think 5 amp power supply plugged into the Power BFF. That is supplying power to the Cutie Pie, 5 volts that it needs. And then you can see I'm running my power and ground from the Power BFF over over the Stemma cable to the NeoRGB Stemma board. And the white wire there is actually running to one of my GPIO pins. I just soldered it underneath there. So that is sending NeoPixel signals. It thinks there's a NeoPixel there. But what you can see that's happening here is my RGB strip is plugged into the red, green, and blue and common anode lines. And so this is running through a nice little RGB type of demo or color fading demo. This one is an ESP32 Pico board, so it is on Wi-Fi, and I'm actually using the WLED software to control it, so it's a really easy to configure, kind of no-code solution. So here you can see I'll switch over to just a single color. And now we can go through and just set it to individual colors. We can adjust that saturation and brightness. And then, of course, the fun part is when you go into some of these effects. Like here's a little heartbeat effect, and you can pick a color palette. So we can say I'm going to use, here's the default color palette, heartbeat effect. Pick an individual color, pick color gradients. So that's all stuff that you can do here, because even though this is not a NeoPixel, the little NeoRGB Stemma board makes your microcontroller think it's talking to one big, long, weird NeoPixel, which is fantastic. Now, what I'll do is I'm going to switch out for a second setup here. And this one I actually, although I am you'll see here, although I am still able to power this Cutie Pie from the Power BFF, I have a USB cable plugged into it so that we can code it in CircuitPython Live. So what you'll see here is I actually am just stealing one pin off of my Stemma QT connector there so that I didn't have to solder anything. And so that's acting as my NeoPixel out. But here is my Stemma board, and here is a big giant strip of this analog RGB strip, is that what we call it? Yeah, big analog RGB strip. Not digital, not NeoPixels, but we're going to talk to it as if it were. So what I'll do is I'll switch over to my code view here. And so you can see what it's running right now is a sort of simple color wheel. It's running through a color wheel code. But what I wanted to do was interrupt that. So in my REPL, I'm going to interrupt that. And then I'll show you just line by line how simple it is to talk to this. So I'm going to go ahead and import the board definition and NeoPixel. I'm going to create a NeoPixel strip here, named strip, that has a single LED. So that's what this one is here, and a pretty low brightness. Just because I plugged things in wrong and screwed them down and was lazy, I'm going to switch the GRB order to BRG. It's just which one is red, green, and blue. And then I'm going to go ahead and set the one NeoPixel that's connected to this to black or off. And then I can go in here and pick individual colors if I want this to be green. Oh, I still have it plugged in wrong, don't I? Okay, that should have been green. RGB, right? Oh, that's funny. Let's go here. Yeah, and that'll be green. Okay, still have the order wrong. What the heck order is this thing supposed to be? Here's red. Red, I think, is actually connected properly. There we go. So you can imagine now any of your NeoPixel code, if we go ahead and run this code that's up there at the top again, that's what's on the board, you can see we're running through one RGB NeoPixel that gets sent out over the Stemma QT, or rather over the Stemma board to adjust this, this giant strip as if it were a NeoPixel. So really fun to work with and a really great combo. So you can see there these two playing really well together. Particularly happy about having a way to mount a, I can light that with this strip actually, a way to light the, I'm really happy about having a way to mount the QT Py to something like this swirly grid here, because we have the little mounting points on the Power BFF, so that's kind of nice. And you can also see if I unplug this CircuitPython example that I had there from USB, it's still running because it's all running off of that Power BFF. So there comes 12 volts incoming to the Power BFF, sending that 12 volts along to my strip here, and it's sending 5 volts to run the QT Py up top. So, and now I've loosened a connection and it's flashing at me, so we'll move that off to the side there. So let's see, what questions do we have before we go any further? I'm going to check in the chats here. None. Okay, good. We're good and clear. Yeah. So Jeff Hunt had asked if the standoffs come. I think these were what you were referring to. Hopefully, maybe not. Oh yeah, these are nylon 2.5 M2.5 standoffs that I'm using to connect it to this. If that's the question. So this did not come with those, just because you might have different mounting needs and want different lengths of standoffs and such. So that's using our little nylon M2.5 kit that we sell in the store, but any M2.5 fastener will work. You can see I'm using one on the NeoRGB Stemma as well there. So it does come with the header pins or sockets, header sockets to plug your QT Py down into. So yeah, so these are some of the different types of strips that you can use here. If you go to the LED strips page, you'll see some you don't want. Digital RGB LED, you don't want those. In fact, I don't know how you talk to those. They're not NeoPixels, they're a different digital RGB type. That's not what we're using. This you could use. This is an analog RGBW, so it has a fourth color that you won't be able to address from the one stemma. But you could say, hey, you know what? I've got some. I want maybe just red, green, and the white LED, and I don't need blue for anything. You could pick those three to plug in, or as Lady Ada said, you could have a second NeoRGB Stemma. Connect it as if it's a second NeoPixel, and then you'll be able to just plug in that fourth LED that's on those. So no digitals. This one's probably an analog here. Any of them that say analog for sure. Side light flexible, analog RGB, those are great. That's similar to the one I'm using here. It's nice sort of neon style one. This would also be great for doing neon style signs. So if you do, you know, Joe eats pizza. If you have like blinking single color strips, you could have each of those strips plugged into one of the connections on that NeoRGB Stemma. So a nice way to do that sort of thing without having to wire up all your own transistors, which is great. All right, I think that's going to do it. Yes? Let me know if you have any other thoughts, questions, comments in the chat. Otherwise, we will wrap that up. Let me put that right there. I'm going to crank it up because under this lighting, you can't really see that. In fact, let's turn that down a little bit. Are these? Yeah, all right. So let's see. In WLED here, crank up that brightness. Woo, yeah, that'll work. And how about for a blink rainbow? That's pretty good. We can adjust the speed. Yeah. Yes, that's going to do it right there. Okay. So those are, let me go to a single view here. That's going to do it for today. Those are my dual product picks this week. It is the Power BFF for Cutie Pie and the NeoRGB Stemma. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you next time. Bye-bye.